Alright guys, this is going to be the video for the chapter review for chapter 5. It's going to be kind of long, but you guys can skip ahead, pause, however you wish to do it. The first question we kind of went through together, so I'm going to go through the first 3 questions pretty quickly since we did it together as a class. Now the first question says the diagram shows the graph of a relation R that maps set A onto set B. Write down R as a set of ordered pairs. So that just means we are going to make a set of each ordered pair. Now we go from left to right, so my first pair is -3, -1. Then from here we see my next point is -2, -2. I have a point here which is -1, +1, as well as 0, 2, 1, 2, and then finally 2, 0. So this is a set of all points. And then we have to explain why R is a function from A to B. So if we look here, there's different things you can do. You can do the vertical line test and check to see if, when drawing a vertical line, we ever have 2 points. You can also look at your set of ordered pairs and see if you have any repeating x's. Either way, it passes the vertical line test, and it also does not have repeating x's. So there's a lot of different reasons on why you can explain it. One of them could be it passes the VLT, or it passes the vertical line test. We now have to write down the domain of this function, and so in this case, what we're going to do is we're going to say, okay, well, domain are all x values. You can hear my dog in the background. So if we look at our x values, you have these x values here. You have -3, -2, -1, 0, 1, and 2. X values are the first number in a set of ordered pairs. So we have, I will write it here, domain is, and we write it from least to greatest with no repeats. So I have -3, -2, -1, 0, 1, 2. And that is the set of all x values. Range is going to be the same thing, except it's going to be all set of y values. So -1, -2, 1, 2, 2, 0. So I still write it from least to greatest. Be careful, do not write it in this order. If you write it in this order, you'll have -1, then -2. Go from bottom to top. My lowest y value is -2, -1, 0, 1, 2. And I don't write repeats. So you'll notice that you have 2 2's. You only have to write that 2 once. So anytime you're writing domain or range, we always write it from least to greatest with no repeats, where domain represents all x values and range represents all possible y values. And then that is number 1. For number 2, you are just stating which of these graphs does not represent a function, and you're going to give a reason. Once again, this is where we use our vertical line test. So where we draw a vertical line, if it hits twice, then it is not a function. So this one's not a function because it does not pass the VLT. Here, however, no matter where I draw my vertical lines, it always will only hit once. So this one is a function. It passes the VLT. Although this one looks pretty weird, it also passes the vertical line test. It will always hit once. This one, however, it's a circle, so it does not pass the VLT. It does not pass the vertical line test. Number 3, we said, okay, for each of these functions defined by their graphs, we have to determine I, whether it is many to 1 or 1 to 1. Part 2, write down the domain. Part 3, write down the range. Notice here, since you never have any repeating x's, because it passes the vertical line test, also because it never has any repeating y's, because it will never hit horizontally more than once, it is 1 to 1. So the first answer for number 3 is 1 to 1. And then we have to write down the domain. Similarly, domain is all possible x values. This is a continuous function, so for this one, since it's not separate points, I do not write my domain as a list. I'm going to write my domain as an inequality. So my domain is going to be number less than x less than x. Range is going to be number less than y less than y. Now if I'm looking at my domain, we have to consider, okay, what's my least amount of domain? Now notice there's no endpoints, which means, like we talked in class, this is implied, it goes on forever here. Similarly, since it doesn't have a dot and it does not signify there's an endpoint, it goes infinitely here. So it'll go infinitely to the left, so it goes up to negative infinity, and it goes infinitely to the right, positive infinity. For my range, it's still going infinitely downwards, so negative infinity, and for my y, it's going infinitely upwards, positive infinity. Now, anytime you have negative infinity to infinity, we use this fancy R, which means all real numbers. It includes negative infinity to infinity. If on the test you write that, that's fine. It means the same thing. Just be aware, anytime you see this fancy R, it just means all real numbers, all numbers from negative infinity to positive infinity. And for my range, same thing. Since it goes from negative infinity to infinity, my range is all real numbers. For part B, for question 3, we still have to answer the questions 1 to 1, all that stuff. So you'll notice it does pass the horizontal line or the vertical line test. So it is with no repeating x's. However, if I do a horizontal line, notice here I have a lot of repeating points. So you have -2 going to 8, you have 1 going to 8, you have 2 going to 8, you have many x's going to the same y, or many x's going to one y. This is many to 1. Then we have to write our domain and range. Notice here it does specifically show an endpoint. This does not have an endpoint. So that's going to affect my domain and range. This one, since there's specifically an endpoint, is saying I'm starting here. Since there is not an endpoint here, it's saying it's going infinitely in this direction. So if I look at my domain and my range, my leftmost point for my x is going to be the -4. And my rightmost point, we'll notice it goes infinitely onto the right, infinity. Now we also talked about the difference between closed and open circles. If it is a filled in circle, we also have to include the bar. So -4 less than or equal to x. So what this is saying is I have all x values from -4 all the way to infinity. Now for my range, it is bottom to top, so my lowest to my highest y value. My lowest y value is this -8 right here. Oh, that's an infinity. That -8. And my highest y value, well, although it does go infinitely here, notice it does not go infinitely upwards. It stops at 8. My graph will never go higher than 8. So my graph will go from -8 to 8. And that is my range. For part C, it does pass a vertical line test, so it is possibly 1 to 1, but we have to check if it's many to 1. So do we have any different x's sharing one y? Well, -2 is on its own, 0 is on its own. However, notice at 1, we have 0 at 1, and we have 4 at 1. Or we have many x's going to one y. This is a many to 1 function. And we're going to set up my domain and my range. Oops. Range. My leftmost x value is -3. My rightmost x value here is 4. And notice they specifically do have endpoints, so I am stopping. I'm not going to infinity. Now, since they both do have endpoints and they're filled in endpoints, they both should be less than or equal to. Now for my y, my lowest y value is -2 right here. And my highest y value is right here, and this looks to be 3. So, lowest -2, highest 3, because this is your highest point. Now, a lot of students will get confused. Your endpoints are not always your lowest and your highest. So my graph does go higher than this endpoint. And then this one has a closed circle, so less than or equal to. This one does not have a closed circle, but unless it's specifically showing you in an open circle, so for example, unless it specifically shows you an empty circle, always assume it is closed. Therefore, that +3 right here does count as less than or equal to. Finally, we have this one. You'll notice the same thing happens here. Oh, here we go. In that, if I look at my function, I have two different x values, -2 and 0, sharing the same y value, -1. So I have -2, -1, and 0, -1, which means it is many to 1. And then if I'm going to do my domain and range, I set up my problem. And I start filling in my values. So first I say, okay, well, my leftmost x value is clearly at -2 because there is an endpoint, so it's not infinity. My rightmost x value is +1, and there's clearly an endpoint. They're both closed in or filled in endpoints, so they're both less than or equal to. My lowest y value is -2 down here, so this is my lowest spot. My highest y value is +2. And they're both closed in, so they're both less than or equal to. Part 4, the function f of x is modeled by the function f of x equals m of x plus b and is defined by the mapping diagram shown. So if we look at this mapping diagram, you can see, okay, well, I have 2 that maps to 12, 3 maps to f of 3, c maps to 3, 5 maps to 10.5. In this case, to figure out my formula, first I need to find my slope, or my gradient. I have my gradient formula, which is y2 minus y1 over x2 minus x1. You need 2 points for your gradient formula. I'm going to use the points I can only use, which is 2, 12, and 5, 10.5. I cannot use these two in the middle because they're not defined values. I don't know both x and y. So this is going to be my x1, y1, x2, y2. So my y2 is 10.5, my y1 is 12, so I'm going to have 10.5 minus 12. My x2 is 5, my x1 is 2, so you're going to have 5 minus 2. And that should give you -0.5. So that is your slope. So I know I have my general formula, y equals -0.5x plus b. Because I know my gradient is -0.5 or -1/2. You can leave it as a decimal or a fraction. To find your b value, to find your y-intercept, this is where we pick 1 point from my set of points and plug it in. You can either do 2 and 12 or 5 or 10.5. I'll do 2 and 12 to avoid the decimals, but you can use either. So my y value is 12. 12 equals -0.5. My x value is 2 plus b, and I want to solve for b. Now, -0.5 times 2 is negative 1 plus b equals 12. To get b by itself, I'm going to add 1 to both sides. And you get b equals 13. So I can rewrite my formula as y equals negative 0.5x plus 13. So I know my general formula. So if we look at our questions, right here, find the values of m and b, we did that one. M is negative 0.5, b is 13. Find the value of f of 3. F of 3 means what is y when x equals 3. So anytime there is a number inside these parentheses for your function notation, that just means plug in this number for x. Well, if we have the formula, this, you can just plug in x. So you'll have y equals negative 0.5 times 3 plus 13. You'll use your calculator to solve it. So you'll have half of 3, which is 1.5, and that's going to give you a negative 1.5 plus 13, which is really 13 minus 1.5, which is going to give you 11.5. So your answer is 11.5. So y equals 11.5 or f of 3 equals 11.5. Find the value of c. So they want you to find c. So we found going this direction, 3 maps to 11.5 by using the formula. Now we have to go backwards. We know the end result. We need to figure out what x is to get 3. So this time, you're going to plug in 3 for y, and you want to figure out what x value makes this true. So I do not know the x. Notice the c is in the x spot. I know 3 is in the y spot. So if I solve this, oh, I know b is 13. So you're going to subtract 13 from both sides, or you can do end solve. Whoops, 13, not 113. It's going to give you negative 10 equals negative 0.5x. Divide by negative 0.5 from both sides. And that's going to give you x equals 20. So c is 20. For number 5, consider the function f of x equals negative 2x plus 5, where this is my bounded restriction. Write down the domain. This is your domain. Now technically, if we want to write domain in set notation, you can either write the exact same thing, that's fine, or technically it's written in this format. Where you have it inside brackets, you'll say x, or your domain, is the set of values between here. But you can write this exactly the same thing, that's fine. You won't get any points taken off on the IB exam or on my exam. Find f of negative 3. Remember, this just means x is negative 3, so I just have to plug in negative 3 into my function. So f of negative 3 is negative 2 times negative 3 plus 5. Negative 2 times negative 3 is positive 6. 6 plus 5 is 11. So your answer is 11. Find x if f of x equals 4. This is similar to the other one where you're going backwards. Now they're telling you the end result. You need to figure out what x is. So you'll have 4 equals negative 2x plus 5. And you'll work backwards to solve it. You'll subtract 5 from both sides. So you'll have minus 5 minus 5. Let me work it out. Let's say here. Now, ideally, you're working all these out on a sheet of notebook paper and not trying to squish everything on this page as I am. So subtract 5 from both sides. You get negative 1 equals a negative 2. Divide by negative 2 on both sides, and you get x equals positive 1/2. So your answer is 1/2. Or x equals 1/2. Sketch the graph of this function. Don't worry about sketching. Hence, find the range. For the range, you can graph it. You can put it in a graphing calculator. However you would like to do it. Or, since you know this is a linear function, and you know it has a negative slope, we can figure out your domain or range by plugging in each of these values. So first off, we already figured out what we get when we plug in negative 3, we get 11. When we plug in 4, however, you'll have 4 times negative 2, which is negative 8. Negative 8 plus 5 is negative 3. So you have negative 3 and 11. Therefore, my range is going to be negative 3 less than or equal to y less than or equal to 11. Once again, the 11 came from here when we plugged in the negative 3. The negative 3 came in from here from plugging in the 4. And you write it from least to greatest. So that's why I wrote the negative 3 first. Which, if you kind of have an idea of what you drew, it makes sense. We have a negative slope where my x is negative 3. And when we have negative 3, I know I ended up with an 11. So I have a point here. I also have a point at 4, which is as far as my graph goes. And when I plugged in 4, you ended up getting negative 3. So if I sketch my graph, this is basically what I got. And then you would see that your domain is from negative 3 to 4 and negative 3 to 11. So when they're linear functions, this really only works for linear functions. If you get weird equations, you'll actually have to sketch it out. But really the shortcut is just plug in your domain values, your least domain value, your highest domain value, and then rewrite your range from least to greatest. Number 6, find the domain of the function y equals 3 minus x if it is known that the range is a set of these values. This one, they're giving you the range, they want you to figure out the domain. So basically, you'll do the exact same thing we did in the previous one, except we have to plug in all values. So generally what you're doing is you're saying, okay, well, I have negative 2 equal to 3 minus x. And then you want to figure out, okay, what is x? So what x value goes with this y value, with this range? You can solve this different ways. Subtract 3 from both sides. It's going to give you negative 5 equals negative x. So I just did minus 3, which is going to give you positive 5. So 5 is going to be one of your values. If you do negative 1, you'll have negative 1 equals 3 minus x. You'll subtract 3 from both sides, will give you negative 4, which will give you positive 4. If you plug in 0, 0 equals 3 minus x. Subtract 3 from both sides, you'll get negative 3, which will give you positive 3. And if you're not sure where I'm getting these values, just solve these kind of on your own. So for example, for the 0.5, you'll do the same thing we did here. You'll just do 0.5 equals 3 minus x. Subtract 3 from both sides, and you will get negative 2.5 equals x. So x equals 2.5, because you'll divide by negative 1 on both sides. And then for 3 equals 3 minus x. Well, subtract 3 from both sides gives you 0. So x equals 0. So after plugging in all these y values, these are the x values that you get back. And then you just will rewrite them from least to greatest. So 0, 2.5, 3, 4, 5. So domain is 0, 2.5, 3, 4, 5. And that's your domain values that are associated with these y values. 7, consider the function f of x equals 0.5x minus 3. Write down the domain. Notice for number 7, there is no restricted domain. So when we did number 5 earlier, it told you that we are going from negative 3 to 4 for my domain. Here, it's not giving such restriction. Here, I know it's kind of hard to see. it just gives you the function, which means your domain goes from negative infinity and infinity. If you graph it, you'll see it. But linear functions will always have a domain, negative infinity to infinity, unless you're given a restricted domain. And we know negative infinity to infinity can be represented by all real numbers R. Sketch the graph of f, clearly marking your sketch in the axes intercepts. I read that terribly wrong, but it just wants you to make the function. So we have a y-intercept at -3. So it clearly wants you to mark that you have a y-intercept at -3. And then you have a slope of 1/2. So you're going to go up 1 over 2. So you'll just have your graph. You'll go up 1 over 2, up 1 over 2 to make your graph. And then up 1 over 2. So that will give you an x-intercept of 1, 2, 3, 4, 5, 6. It looks like 6. Make your line. Hopefully your sketch is better than mine. You also want to clearly mark the axes. So you clearly want to mark that you have an x and y axes. And then you clearly want to mark that you have a y-intercept of -3 and an x-intercept of 6. You also want to show scaling. So you want to show this is 1, 2, 3, 4, 5, 6, that you're jumping by ones. So that's how you will sketch. And then to find the range, well, once again, we do not have a restricted domain, which means I do not have a restricted range. All real numbers, which makes sense. If I look at my graph, it goes on forever to the left, on forever to the right, negative infinity to infinity, which is represented by all real numbers. It goes forever bottom, it goes forever to the top, negative infinity to infinity, represented by all real numbers. And then you will determine whether these points lie on the graph. There's different ways you can do this. You can put this function into your calculator, look at your table of values and see if it's there. Or you can plug in these x values and see if you get the same y values. You can plug in both values into the equation, see if it gives you a true statement, which is the standard way of checking. So for example, my main function is y equals 0.5x minus 3. And then I'm going to use the same function. I'm just going to plug in for these values. So my y is -2.5. My x is 1. So all I did is for part I took the 1 and put it in for x, the -2.5, put it for y, see if it gives me a true statement. So 0.5 times 1 is 0.5. 0.5 minus 3 is -2.5. So this one is yes. It does lie on the graph because it gives me a true statement. If I try the other one, 46 equals 0.5 times 100 minus 3. Half of 100 is 50 minus 3. 50 minus 3 is 47. 47 does not equal 46. So no. So you just, to figure out if points lie on a graph, you just plug it into the formula and check to see if they give you true statements. If they give you true statements, yes, they lie on the line. If they give you false statements, no, they don't lie on the line. Number 8. The diagram shows the graph of a function y equals f of x. So here's my function. Write down the values of f of 4, f of -6, f of 6. This just means figure out what is y when x is 4. So x is 4. My y value is here at -1. For the other one, x is -6. My y is -2. This is actually kind of blurry. Looking back on it, I think this one's -2. Wait, no. They're both -1. No one saw that. So yeah, it's really hard to see, but there's a line here. So when x is... Wait a minute. Okay. Pretend you didn't see anything. I don't think anyone's listening to what's sound on anyways. When x is 4, it's here. So yes, this one is -1. Because this is the point 4, comma, -1. So when x is 4, y is -1. When x is -6, this is the point -6, comma, +1. When x is -6, y is 1. When x is +6 right here, it's one of my endpoints, I also have +1. So basically they're saying, what is y when x is the number in the parentheses? Now for part B, you're going backwards. Notice they're not giving you x. The x's are unknown. They're giving you the y values. So they want to figure out what is x when y is this number. So for example, what is x when y is -1? Well, if I look at -1, -1 will be down here. Now you have two options. When y is -1, you either have x is 4 or x is -4. When y is -5, down here, you only have one option, which is 0. When y is +2, is right here, you only have one option. X is 7. So once again, if you have numbers in the parentheses, they're telling you the x value, and they want you to find the y value. If you have x unknown in the parentheses, but they give you an output, you know the y value, they want you to find the x value. Part C, the point A, T3, lies in the graph of f. Write down the value of t. Well, this is the same thing as you're doing in part B. They're giving you the y value, they want you to find the x value. So let me clear my graph. So we have 3 for my y value, which is here. And you want to figure out what x value that goes with, which is 8. So this is the point -8, comma 3. Therefore, t equals 8. Or -8. And then find the set of values of x for which x is less than 0. All this is saying is, okay, find all x values where my f of x, my range, is less than 0. Well, when my range is less than 0, it's all x value, or all y values below here. So my y values, find the set of values of x for when this is true. So we have a couple of points. So we are going to not write individual values because it's a continuous function. So we're going to write inequality. Now they want me to find my x values, so this is where I do this. And they only want the x values that are below here. Well, this goes from here to here. So from this point to this point is where I have all my y values less than 0. So I'm not going to include these x values above 0. So in this case, with this new restricted domain, my leftmost value is going to be at -5. Now, usually my leftmost value is -8. However, they're specifying I only want the ones that have negative y values. So that's why I do not include the -8. The -8 has a positive y value. Similarly, my rightmost point is 5. Because although 6 is originally my rightmost value, it has a positive y value. I only want the negative ones. And then these are both, remember, always assume it's closed circle unless told otherwise, less than or equal to. So I have -5 less than or equal to x less than or equal to 5. There'll be another video going over the other problems, so it's not just one giant video. So this is just the first page of your packet.